Lindsay Levine. Lindsay is a student and currently at Venmo, and she's gonna give a cool talk on games and JavaScript and Relay. Actually, I'm really curious about Relay. I was just looking into it this morning. Lindsay, let me get you.
I just need to set up the display. Because Dexa uses, there's like a presenter view.
Oh, you want the presenter view?
Yeah.
Like this?
Yeah.
And then you would go this display.
You do. Oh my thanks. That emoji. Oh my god. It's fun.
Oh wait, this.
What is going on?
Is this? What is this?
This is Dexa?
Okay, I've never heard of it.
I hope this works.
There.
Nice. Yeah.
All right.
Okay. We ready? Is it on?
Is it on? Yeah, it's good.
Hello? Hello? All right, hey guys. So I didn't really know what I wanted to talk about tonight. I was asking my coworker what I should do. I was like, I really don't feel like I have anything interesting or important to talk about. So she was like, well, what do you care about? And one of the first things that came to mind was this Capture the Flag web game I've been playing for like 2.5 years. I'm rocking the shirt right now too. It's like a 4v4 game. Players just try to take the other team's flag and take it back to their base. And my coworker found one thing I said about the game particularly interesting, and that was that my time on TagBro actually inspired me to want to come to Fullstack and become a better developer. So I'll explain why in a bit, but first let me start by actually introducing myself for those who don't know me. So my name's Lindsay, and I'm on the web team at Venmo, and not including Sarah, our team is at most 6 months old, so there's 5 of us. And since joining, we've all worked on a bunch of different things. I've worked primarily on Venmo groups. Some of my teammates have worked on things like how to prevent account takeovers, rewriting settings in the web app, payment links, the Dev API program. But we've all kind of been ramping up to start rewriting our web app. So our current web app is interesting. Venmo's backend is Python, and our web app is a 3-year-old Django app living inside our platform repo, which the web team rarely touches right now. So we started a new web app, and if you log in and check out your settings, you'll see what looks entirely different from the rest of the logged in app. So we're writing in ES6, and we're using React and Flumix, and then our web app's backend is Node and Express, where we render the app on the server and send it to the client. And on that note, we just open sourced this package called, or a component rather, called React HTML document, and it's out on NPM, and it's basically useful for rendering full HTML docs on the server, so definitely check that out. And that's pretty much it for Venmo, so let's get back to TagBro. So this is a GIF, or GIF, however you want to pronounce it, of a normal Capture the Flag game. You can see this red ball trying to take the blue team's flag and take it back to his base, but the blue ball intercepts him mid-flight, so he pops, has 3 seconds to respawn in base, and the blue flag returns to the blue base. So that's like the standard game mode. And then this is a GIF of a neutral flag game where instead of 2 flags, there's just 1 yellow flag that each team has to fight to take back to their team's checkered tiles. That's their goal. So TagBro started as one guy's side project to learn Node way back when, and his name is Nick Riggs, but he goes as Lucky Spammer in the game. And actually all of the devs go by their TagBro names, and they've contributed to the game entirely in their free time and out of pocket, which is honestly amazing to me because it survived for so long, and there's like a dozen servers worldwide and thousands of players. So kudos to them. So I'm just gonna give them a shout out. You have Lucky, Stepin, Enk, Nucomt, Y Lambda, and Lai. So if you decide to play and happen to see one of them in your game, you should definitely say hello. So besides the addicting gameplay and the awesome community, the special thing about TagBro is how easy it is to mod the game. I saw all these players writing all this awesome stuff and all these awesome scripts that enhance the game experience, and I was like, I definitely want to do that. That's kind of what inspired me to want to come to Fullstack. So what Lucky did is expose the TagBro object to the client, which houses tons of data about the current game, the map, the graphics, the players, the score, so on. So you can kind of see here it's a little small, but I just loaded up a game on a map test server, and opened up the console and logged out this tag pro object, which has a ton of stuff that players can use to like write cool scripts and stuff. So supposedly Lucky only did this at first for his own ease of development, but the devs decided to leave it there because of the community's overwhelming response to it. So if you search tag pro on GitHub, you'll find like pages of repos from players who have written scripts, apps or extensions that all hack on the game, and I'll show off a bit later. So before I go on, I just want to quickly explain the difference between Tag Pro Classic and Next. Classic is the game that's currently live, what you see when you visit tagpro.gg right now, and Next is the rewrite of Classic that the devs are currently rewriting from the ground up and improving in a bunch of ways. So this is a pic of what Next is starting to look like. The graphics are way different, and some of the physics are different as well. And then in Next, the devs have decided to actually intentionally write in the functionality to allow players to upload their own user scripts, download other players' scripts, and then run them on Next instead of having to run them on TamperMonkey or GreaseMonkey. So this is a screenshot of TamperMonkey. TamperMonkey and GreaseMonkey are extensions in Firefox and Chrome, respectively, that let you run user scripts on domains and modify the DOM and manipulate the JavaScript in the browser. So that's how players run their scripts on Tag Pro Classic today. So yeah, this is a screenshot of like a chat macros script in the TamperMonkey dashboard. And you can see like the lines 5 through 7, they're kind of small, but they're the include tags that tell TamperMonkey like, hey, run these scripts, or run this script on these domains. So how does Tag Pro work? What tech does it use? Try to run through this because I know David like wants me to go quickly. So first I'll explain some basics. This is what you see when you go to tagpro.gg. You see a list of servers like Pi, Radius, and Origin, which are in Newark, Atlanta, and Detroit, respectively. And naturally, the closer you are to these locations, the lower your ping will be. So in Classic, they have these app servers in these different parts of the country, but in Next, it's pretty cool because they're going to use cloud-based provisioning to spin up game servers by geographical location, depending on who's trying to play at any given time. So now when you go to a server like Radius and you hit play now, the app will spin up a game server on a specific port anywhere between 8000 and 8020, depending on how many game servers that app server has been configured to support. So for example, there's a server called Arc in the Northwest that like nobody ever plays on. Like, does anyone even live there? I don't know. So it probably only has like 6 game servers it's configured to support. And these game servers host WebSockets via Socket.io that the client uses to sync game state with the rest of the players on that game server. So when a user connects to a game, a WebSocket connection is established between the client and the server, and the client will start simulating gameplay and the player's movements every 60th of a second, but in Next they're actually moving to every 1/44th of a second. Whereas the real source of truth will come in a socket event from the server every second or so. And that's decided by Box2D, Box2D Web specifically, which is a physics engine that basically takes all the data from every client on the game server and decides what the actual game state should be and what the source of truth should be. So when your connection is faulty, the client will continue to simulate the player's movements or the game state until it hears the truth from the server. So if the truth is considerably different than what the client's been simulating, that's when the player will experience what we know as lag. So the specs of the game are things we've definitely seen before at Fullstack. We all should recognize at least half of these, some of us maybe 3 or 4. Pixie is just the WebGL rendering engine that handles the game graphics on the client, and I mentioned Box2D a little bit earlier. Okay, so how fast am I going? I can't even tell. So one thing I do want to mention, because the devs are going to publish this soon, it's a library they wrote called Intercom, and it's just an RPC or remote procedure call that lets their servers talk to each other. The purpose being to abstract away HTTP requests between the servers. So an example is like someone tries to log into Radius, an app server, sends a message through Intercom to the user server being like, hey, do we have this user already, which messages the DB server. Intercom sends a result back to the user server, which returns the original promise to the original app server, saying we do or do not have the user. So I'm just gonna breeze through this. Yeah, so this is just like some fun stuff about like they moved Tag Pro Next to use React, Redux, and PostCSS for non-game pages like groups, but who's actually interested in this? Anyone? Okay, we're moving on. The Tag Pro API is pretty straightforward. It describes the Tag Pro object I showed earlier, what's available in it, the socket events that occur throughout games, and how to subscribe to them. So now I want to talk about all the cool things players have done with this. So bots. We've had players write scripts that control balls in the game and compete against each other and other bots. And then Ghost was actually just like one guy who wrote this one thing. This is kind of dark, but there was one It was a birthday event, so the devs decided for TagPro's birthday they were going to completely rewrite the physics of the game and turn it into like this Mario gravity. So they had this map where every player in the game would like sign on and race to the top of this tower and try to win a Mario flare. So we took the eight fastest players in all of TagPro and streamed an event of them racing against each other. And one of my really good friends, he goes by Ball Parts. He worked on my side project with me, and he decided he was gonna like write this script that would show the ghosts of the previous race winner's race. So these red balls, if you can see, I don't know, my eyes are pretty bad right now, but if you can see, they were the players that were racing live, and that blue ball at the top is the path of the previous race's winner, which was really cool and made for like a really interesting event to spectate. And it was cool to watch him like learn more JavaScript by working on this, because he's like actually like a psychologist with an MD, and he's not like a developer for his day job. So we also have map editors, so people who like built their own map editors to allow non-devs and regular players to make their own maps and submit them to be in the game. Managers that let you change like the graphics you see when you're playing, because the default texture pack is kind of bland. Scripts that make your ball spin or change the particles you see when you pick up a power-up. Scripts that let you draw when you're spectating a game for better gameplay analysis. Stat scripts, replays, also done by Ball Parts. It revolutionized TagPro montage. So you click a button in the top right of your screen, and it basically downloads the last 30 seconds of your game in raw data, and then lets you render it and download it as a web movie later. Some 3D interpretations and an Android clone as well. So this is a screenshot of TagPro replays. You can see I have like a bunch saved. You can watch your replays in the extension, crop them, render a bunch at once. TagPro Analytics was done by a European player, so when you're running the analytics script, it will upload all that game stats to tagpro.eu and show you a bunch of cool stuff about the game, like a map of where everyone had popped during the game. And also a detailed breakdown of what every ball was doing at any like given second in the game. So this brings me to mltp.info, which was my main TagPro project, which I did first back when I was a Fullstack student between junior and senior phase. We had a month-long break. Shout out to Zeke and Christian Sakai who just talked, because I wouldn't have been able to finish this project without them. And mltp.info aimed to solve two problems in TagPro's biggest competitive league. Number one, it wanted to help captains better collect stats because they were manually downloading CSVs through another person's script, and then manually uploading them to a stats keeper. Number two, it wanted to serve as like a live scoreboard for the league that spectators of the league could go and see all the scores of the games updating live. So it's both a site and a user script. Captains run the script every Sunday night during their games, which listen to score events in the game and make requests to my server, which updates the clients with game scores live. So Ank, one of the TagPro devs I mentioned earlier, was really big on Koa at the time. So I decided to give it a try, which is another example of how it helped me grow as a dev, because it gave me the motivation to try out a new technology when I otherwise wouldn't have. So it was originally Koa, Angular, and Mongo hosted on Heroku. But I don't know if anyone else had this problem. Recently, MongoLab upgraded their free sandbox databases to, see some nods, to Mongo 3.0, and my Mongo driver was no longer supported. So I could have upgraded to like a paid subscription, but obviously I didn't do that. So if you go to mltp.info now, there's no data, because I'm currently rewriting it using something called Relay. So what is Relay? Some people consider it to be the next evolution of Flux or a simplification of Flux. So React alone is often described as the V in MVCs. So React and Relay try to work together to provide a more full package solution like Angular or Ember. So in Flux, you have one-way data flow where a component triggers an action, which updates data in a store, which passes that updated data to any component subscribed to that store. But in Relay, there's one global store, I guess kind of like Redux, for all of your app's data. But the difference with Relay is that each component explicitly defines what data it needs in the form of a special query. And then Relay does the dirty work for you by like aggregating all of those individually defined queries into one single query, thereby eliminating duplicated requests and preventing any overfetching or underfetching of data. So it seems pretty magical, right? And in a lot of ways it is. One of Relay's tricks is that a component won't be rendered until all the data it's requested is available. So there's something called Relay's root container which will come into context in a bit, and that accepts 3 optional callbacks as props. That's render loading, render fetched, and render failure. And these give devs total control over the render behavior of their top-level components. So if you want to load like a spinner or a loading state, it's as easy as just passing that component to the render loading callback. So by enabling this idea of co-locating queries with the view, developers don't have to worry as much about like moving these components around their view hierarchies. And they can do so without having to like apply a dozen of changes to prop definitions in all of their parent components. But that being said, there's a lot about Relay that's new and isn't magical, and there's an undeniable learning curve. So does everyone remember being shown this graph about learning Angular? Nice, okay. I wasn't sure if it was being shown after my cohort. So I drew a beautifully composed graph in Photoshop of my feelings about Relay over time, and that gray dotted line is kind of where I see myself at right now. So up there at the beginning is when I initially learned about Relay and thought, wow, okay, like data fetching done for me. It sounds really, really easy in theory. But I quickly realized it's not so easy in practice, which is that pretty steep dive downwards. I found that Relay is not quite as easy to pick up as React for a lot of reasons, but mainly the big reason is that Relay requires that your server have a GraphQL from which it can fetch its data. So GraphQL is Facebook's query language, built with the client developer in mind. It's intended to help client apps fetch data more efficiently than RESTful endpoints, which is great for Relay, but GraphQL itself is also like not so easy to pick up. So let's just try to focus on Relay for now. So we'll start by defining the data a React component needs by wrapping it in a Relay container. So here we have a standard React component. For the record, this is kind of like an example I abstracted from a Facebook blog post. And this component takes a story prop and shows the author's image, his or her name, and the story's text. So now what we can do is wrap that story component using relay.createContainer, which takes as arguments a React component and another object that defines your queries. So you can see here, this query is in the blue in the form of like an ES6 template literal. And it's shaped just like the structure of the story prop that our story component expects. So story expects like author, profile picture, URI, author name, and text, and that's the exact shape of that blue object there. So similar to how JSX transpiles to plain JavaScript, these template literals transpile to plain objects that describe a component's queries using something called the Babel Relay plugin, which is on NPM, and you can see how it's used in Facebook's Relay Starter Kit. So Relay queries on a component can compose queries from child components too, using this syntax component.getQuery, which takes as argument like the proper query name as a string. So let's say we have a newsfeed component that uses story, and we want to get the story data at that level without hard coding it there too. We can use that syntax to compose a child query at that level. And by doing that, if someone updates the story's query to fetch a little more data, newsfeed and any other parent component of story, like maybe a profile component, those parents don't need to be updated at all. So the way the web team at Venmo tries to handle this in Flumix is that we have a top-level component, let's say it's called settings page, which has a fetch data static. And then on our server, before we render, we check every top-level component for that fetch data function. And if it exists, we run it, which is usually just like a promise.all call of a bunch of actions as promises that are registered to that component store. And then when that top-level component has fetched all of its data, it will iterate over its children using react.children.map and react.cloneElement to ensure each child component of the top-level component gets the data it needs and the necessary state from the store as props. So it's kind of like manual Relay without the fetching optimization. Plus, we still have to pass store states around to any nested views, which means there's a lot of data leaking to components that don't need everything that the store has to offer. So, yep, not gonna go through this, no time. So, let me see what's worth talking about. Okay, I do want to talk about how like this kind of data fetching pattern in Flux might be bad or might cause problems. So, like in some Flux implementations or in plain old React, it would be much more painful to like. Let's say that we had a post that renders like a title and a body. Let's say we wanted to add a timestamp to this body. Then you might have to like change a lot of prop definition updates in all of the components parents, and then you might need to write like a new Flux action or a new API request to ask for that additional data. And then in that, if it was relay, then you would just like change the query definition in body, and that's it. And another example is like, let's say that someone edits an endpoint to no longer send a piece of data without realizing that a tiny part of your complex view hierarchy depends on it. Then you find yourself with an underfetching problem that just wouldn't happen in a properly configured relay app. So a few last things. This will be quick, David, I promise. Let's go back to the newsfeed container and talk about these query params. So basically what we see here is it's just defaulting the number of stories we initially want in our feed. And these would be available to the newsfeed component as this.props.query params. And they could be modified with set query params, which just take the new params as argument. So if you're lazy loading a feed like Facebook's, let's say as you scroll to the bottom of your feed, this load more function gets called, and when set query params gets called, within load more, Relay will send a GraphQL request for 5 more stories, and after those stories are fetched, the component will re-render with the additional 5 stories available in its props, which is awesome because it makes things like lazy loading and pagination really easy. So wait a sec, it sounds like Relay can only query for data. How do we handle writes? We have these things called mutations. So GraphQL not only supports reads, it supports writes in the forms of mutations, which are a GraphQL object type that needs a few different things. Basically, it needs to know the type of mutation you want to perform, any variables the mutation expects. In the example I'm about to explain super quickly, it's the idea of the post you want to upvote and a query for the updated fields that the mutation might change. So another magical part of Relay is that it takes that query, referred to as a fat query, and doesn't intersect with the data that Relay's already been tracking in the store. So it basically does another double check to make sure we're only retrieving the data we need and determines the right mutation query to pass to the server. So if we revisit our blog example from earlier, imagine we've written a mutation called upvote post mutation in our GraphQL schema, and we define that by just extending relay.mutation and referring to what we named it server side in this function getMutation. And then to trigger it, we just instantiate a new instance and pass it to relay.store.update, which also takes on failure and on success callbacks. Mutation type here would just be a fields change, since all we're doing is incrementing upvotes by 1 on the specific post ID we provide, and all we expect to change in the fact query is just the number of upvotes on the post. So this is actually like the end, I promise. Relay mutations also support these things called optimistic updates that give users instant feedback on an action they perform instead of having to wait for a server's response. So all you have to do is return an object that mimics the shape of the payload we expect from the server once the mutation has completed. So building off that example, we can optimistically expect that the server will increment upvotes by 1 once the mutation's completed. So a lot of this is a lot more complicated than I've touched on. Relay's still really, really new, and starting is kind of like entering uncharted territory and figuring out things on your own a lot. But that being said, it's being used in prod at Facebook, so it's pretty telling about how reliable it is in highly complex client apps. So I think it's worth exploring as it becomes more supported, but for example, right now Relay doesn't support real-time subscriptions, so for me, in mltp.info, that live page, which is like the most used page of the site, it will use data from Relay's centralized store on page load, but then we'll thereafter have to accept props from a decorator component that's subscribed to socket events from the server. So that's pretty much it. Thanks for listening to that mouthful. Hopefully you guys check out Relay and TagPro. And yeah, thanks so much to Charlotte and Fullstack. Love you guys.